Hello and welcome to part 8 of Dev Maths and Stats Refresher Course, Lecture 2. And now we're going to round off this section on combination rules for differentiation by looking at mixed examples where you can use combinations of the rules. So this is almost an optional session, there's nothing new here. So if you're finding it all very easy, you can skip this video. But if you want to practice this, I strongly encourage you to try each example yourself and then look at my solutions and see if it's okay and ask if you have any problems. So I'll go through one by one. I'll go through step by step, but you can fast forward if you like. So I'm going to start with this one. Y is equal to 2x power 6 e to the 8x. Okay, now this one combines two rules because we got a product rule, this times this, 2x power 6 times e to the power 8x, but this part itself we don't know how to differentiate yet, though you may have a clue. This part itself we have to differentiate using the chain rule. So what I would do is, if you want the full story, is to take this off to the side and let's imagine we're doing y is equal to e to the power 8x. Now of course this y is being lazy, this y is not the same as this y now, it's a different y. This is just to get the different derivative here. So y is equal to e to the power 8x. So using the chain rule you could see this in a simple form as y is equal to e to the u. Let's bring u in here. But then u, you have to remember, is 8x. So now you need to differentiate both these. So you need dy by du is e to the power u, and du by dx is 8. And now you can get from that dy by dx, which I might want to write as y dashed in a minute, is equal to this times this using the chain rule. So e to the power u times 8 e to the power u. Finally remember that u is equal to 8x. Now that's how you do the full thing here, that first stage using the chain rule. But when you get more practice you realise that when you differentiate this e to the power 8x stays the same, and you simply multiply by the derivative of this part. So you have 8 e to the 8x. But this is how you write it in full. Now we have that, we are now ready to do the second part, which is the chain rule part, and we're looking at this times this as u and v. Okay, to avoid bringing in too many letters, I'll stick with u and v, even though the u is different from this u now. So forget that u. Y is equal to uv. U is equal to 2x to the power 6, and v is equal to e to the 8x. Get the derivatives here. 12x to the power 5. And here we have to use what we've just done. V dashed is 8. X makes e. Goodness, for undo 8x. That's from this. That's how you differentiate this using the product rule above, the chain rule above. So here we have the product rule set up, and we can get the final answer now, which is that y is equal to this one times this one. So that's 12x to the power 5 e to the 8x. This times this, plus, because it's the product rule, this one left alone times this one, so 2, let me write it in one go so it's work out, I'll do separate bits, so 2x to the power 6 times 8 e to the power 8x. And then you can tidy up a little bit by saying that here, I won't simplify completely because it might confuse more than not. Plus 16 x to the power 6 e to the power 8x, because you have the 2 times the 8 is 16. And then you would want to take out some common factors. So from the 12 and the 16 you can take out a 4, you can take out an x to the power 5 from here, and you can take out e to the power 8x. So this leaves a 3 there, you get that, and it leaves a 4x there. Okay, so that completes the answer. So you've got the two stages of using first the up here the chain rule, and then once you've got the chain rule, then you know how to differentiate this. Then you can use this times this as the product rule to get here, and then just simplify at the end. Okay, it didn't simplify, it didn't factorize, but I think that's the answer from here. Okay, so on to the next. So now we're looking at y is equal to 5p squared divided by 3 brackets so 5p squared divided by 3p minus 2 all squared. So here could use the product rule, but I think we use the quotient rule and do it properly. So in the quotient rule we'd have u is equal to 5p squared, b is equal to 3p minus 2 squared. So that's the top part and the bottom part. You need the derivatives. I said it was going to be a combination. I forgot to do the combination part. Okay, here we have to pause, and we're going to, because we don't know exactly how to differentiate this yet, so when you get more used to it you can do it in one step, but really we want to use the chain rule to get a derivative for this part. So using the chain rule, you have to imagine we're looking at v is equal to, choose another letter, we've not had much today, we haven't had r really. So this is v is equal to r squared, but r is equal to 3p minus 2. So dv by dr, v and r is a dangerous combination, looks the same, is equal to 2r, and dr by dp is just equal to 3. So the thing we want to have dv by dp, so that's dv by dp is just these two things together, so 2r times 3, which is equal to 6r, and r is 3p minus 2. So that's the derivative we need here, 6 times 3p minus 2 is the derivative we need here. So that differentiate this, you get this. So if you don't know how to do this, you have to use the chain rule here, but that's got us to this stage. Now we have all the parts you need for the quotient rule. So we can say that using y dash is equal to this times this, so 10p times that. This differentiated times that staying the same, minus this staying the same, times this differentiated. And then all divided by 3p minus 2 squared, that's what's there, squared, so you can put another brackets to show how the whole of this is squared. So it's 3p minus 2 to the power 4. So on the bottom you've got this bracket to the power 4. On the top you've got the bracket a couple of times, so you can cancel it out here. So the first term would look something like 10p divided by 3p minus 2 just squared. Because here you have the power 4, you have the power 2, so it cancels out like that. Minus, and then you have 30p squared divided by 3p minus 2 to the power 3, because there's only 1 there to cancel out. And this hopefully gets us somewhere near to the Maple answer. But let's see if Maple will give us a thumbs up or a thumbs down. For me, I would 10 over squared. Yes, good. So we have that one correct. Okay, the third example, I'll pick up from here. So this is one we have y is equal to e to the x squared divided by x. And this looks complicated, but it is something that actually occurs a fair amount in statistics and other places, so it's worth knowing how to differentiate this. So e to the x squared divided by x. We're going to use a quotient because it's this divided by something, but this thing up here we don't know how to differentiate yet. So we're going to use first, remember to do it this time, I'm first going to look at how to differentiate this part using the chain rule. Let's make a space for that here. So let's say that y is equal to e to the x squared, and I'm being lazy because this y is different from this y now. Y is equal to e to the x squared, so I would visualize this as y is equal to e to the t. I don't need t's yet today. Maybe it's because I need some t. And t is equal to x squared. So dy by dt is e to the t, simple. And dt by dx is equal to 2x. And then we can assemble that together. So what we want is the dy by dt here, or y dashed. And that's going to be equal to this times this. So 2x e to the t. Oops. E to the t. And finally remember that t is actually x squared, so it's 2x e to the x squared. So this is the derivative we need for that top part. And when you get practice, you realise that e to the x squared, if you differentiate it, the e to the x squared is still there, and you just multiply by the derivative of this. So after some practice, you don't need all these steps. You can do it in your head, but that's what we need for now. And now we can go back to the main part, doing the overall thing with the quotient rule. So u is going to be e to the x squared. No room with that. There. That's u and that's v. It's going to be just x. Simple. U dashed is, differentiate this, we had from here, 2x e to the x squared. V dashed is just 1, that's dead simple. Then we get the overall answer being this times this. So 2x easy x squared times x is 2x squared. That's this one times this one. Minus, because it's quotient rule, this times this. And then don't forget to divide by b squared, which is x squared. So it doesn't come out too horrible, this one, because the x squared cancels here. So you have 2 e to the x squared. That's the like an e. Minus e to the x squared over x squared. And you could change it around, you could factorise this out, but that's probably about as good as you're going to get. So let's see if we're on the right lines. That's pretty good. Okay, so we move on to the final example, this section. Quite a long expression there. So make sure you pause it and have a good try yourself on this one. We paste it in and try on the screen. So y is equal to 9 u to the power 4 times 3 minus u to the power 3 plus 9 minus u to the power 4, 9 u to the power times 3 minus u to the power 3 plus 5 log u divided by u to the power half. Let's give the full version of this and say what it would look like. 5 log u. You're more likely to meet it looking at something like this. Which looks a bit horrible. So, yeah, 5 log u divided by u to the power half, which is the square root of u. So, what we've got here is something we can split into many parts. This part here is going to be that times that, and then this part itself, you need the chain rule to come up with an answer for that. And this part here, 5 log u over square root of u, is just a quotient rule with this divided by this, so that's not so bad. So it's just going to be a product rule and a quotient rule, but before we do the product rule, we need to figure out how to differentiate this. So I'll just take this off to one side and do the chain rule on that part. If you had a function y, a different y that was like this, then I would visualize that as y is equal to, I haven't gone all the way to z yet. This is the last example, so let's have z cubed, and z, we remember, is 3 minus u. So then dy by dz is equal to 3z squared. dz by du is equal to negative 1. So dy by du, which is what you need, is equal to, that's y dashed, is equal to this times this, so it's minus 3z squared. That minus, which is minus 3 minus u squared. So what's happening is that this to the power 3 goes to this to the power 2, and you multiply by the 3 and you multiply by the negative 1, which comes from this derivative here. So with practice you could just go straight from here to here. So now we have everything we need. You can get going with different stages here. So y is equal to, first product rule, So we're going to do, I need a bit more space to write it like this. Product rule I write as, if I call that, let's have that A and B, and then, that was good, pretty good colour coding. And I'll do something similar here for the quotient rule. I have this as C, and this as D in a minute. So A times B first, so A is equal to 9 u power 4, B is equal to 3 minus u to the power 3, so A dashed is equal to 36 u power 3, and B dashed, got from up here, is minus 3 minus u squared. So completing this part here, we need this times this, so it's 36 u to the power 3 minus u cubed, plus 9u4, well, okay, plus and then a minus, so minus 27 u power 4 3 minus u squared. So that's this part differentiated using the product rule, this times this. So it's this times this, 36 minus u cubed, and this times this is that part. Still have not done this, which is the quotient rule, so I'll do that over here using this coding C and D. So C is 5 log u, D is, and let's make life easier by saying that it's u to the power half. That's the same as square root u. C dashed is going to be, differentiate this, 5 over log u. Oh, no. Rule is 5 over u. Differentiate this, and it's d dashed is half so half times 1 is a half, and u to the minus a half, which is 1 over 2 square root of u. And now we can put this together to get the quotient rule part added onto this. Adding on, quotient rule is this differentiated times this, so it's 5u times u to the power half, or, sorry, 5 over u times u to the power half, minus 5 log u over 2, let's do it like this, over 2, u to the power half is, let's put it back in this form. Actually, that's not consistent. This. So it's the 5 log u on top. So 5 log u divided by half u to the this, and then divided by v squared, which is actually nice this time because u to the power half squared is the square root of u squared, it's just u. And then you can do a grand tidy up on that, which I don't think we'll go through the whole thing because the video is 24 minutes long already, crikey. So I think I'd leave this pretty much as it is for now, maybe take some common factors of 9 out of these things here, 3, so you could take, so this first part you could take a 9 here, and u cubed, and 3 minus u to the power of 2 from that. So in the bracket you'd be left with 4 lots of 3 minus u plus 3 lots of u. So that sort of makes sense to do. And then this part here, just divide everything by u. So you can have, that's very ugly, u squared, this is u to the power half divided by u squared is 5 over u to the power 3 over 2 minus 5 log u over u to the power 3 over 2 again. So still looks pretty unpleasant, but let's compare it with what we get here. Doesn't look much better in Maple. So I think this is sort of familiar. Yeah, it didn't even factorise that. Yes, that's what we're getting. Okay. So it looks good. Okay, so the next section we'll go on to look at something which is occasionally useful, which is called implicit differentiation. But we've now covered the main meat, or the main tofu, or halloumi of what you're going to need to know in terms of rules. So we'll look at implicit differentiation next and then go on to some applications. But for now, thanks for watching.